Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
I will introduce our collaboration, and Fiona will go into kind of detail both about the kind of mathematics and the kind of hard work that he's been putting in kind of realizing or exploring what we've been doing. Basically, we've been looking at narrative and the kind of mathematical findable properties of narrative, starting with looking at screenplays, which I teach screenwriting at Royal Holloway, where Fiona is Professor of Computer Science. We came together to supervise a doctoral student who was interested in improving screenwriting software. And it then became apparent that there were a lot of kind of interesting problems which the screenplay solved, because it presents narrative data with a lot of metadata attached that is relatively easy for a computer to understand. But it also has a screenplay has been a model that has been designed extremely well as a story which conveys information in real time, and which kind of over about 100 years of the screenplay is actually enormously efficient at creating stories that work. So in analyzing screenplays, you're also kind of being able to look at how stories work, and we've been exploring kind of how much of the kind of heuristics of narrative that a screenplay should have or is assumed to have can be deduced through the kind of correspondence analysis techniques which Field's been using. Yeah.
Am I right in thinking that screenwriters also make heavy reliance on tools already?
Yes, they do. I mean, both, there are numbers of softwares that kind of help with the formula, but there are a lot of books which kind of say this is how a screenplay ought to work, or these are the properties of a screenplay. To what extent it's profitable to use that model is a moot question, and perhaps when we come on to questions, we can look at kind of how that works. But I suppose the question is, can you find narrative structure in a screenplay text? And maybe that's the point where Phil will kind of explain what kinds of structures we found, and maybe also what uses we think can be made from them.
Okay, thanks, Adam. And thank you, Tori, and thank you all for being here. Now, I'll just begin with a little overview of the methodology used, the algorithms, the correspondence analysis, and so on, which I've characterized here as a platform, meaning that there are lots of uses, and I'll give plenty of examples during the course of the talk. And first of all, I mean, correspondence analysis is a bit like principal components analysis, if you know about it. It's dimensionality reduction. So you have a high-dimensional input data space, and you basically map that into a low-dimensional space. Now, that can be of use for visualization. In a lot of the work here, though, however, we're going to be using the full-dimensional representation of the data in a factor or principal component, if you really wish, space, which is Euclidean, and using the full-dimensional space to do other things with it. The most important of those techniques is clustering, and I'll show you just in a few moments' time why hierarchical clustering actually encapsulates change, anomaly, or exceptional circumstances, which is a bit counterintuitive, but I'll show you just why that's the case, and then give examples of how that then is put to work in practice. So we're dealing with metrics, which give rise to a distance measure, and that defines a space, an information space. Okay. And an ultrametric, which is the distance on a tree or hierarchy. And because correspondence analysis, in a very particular way, weights the rows and the columns, for those, as you will see, most of the talk will be dealing with scenes from the film script crossed by the terms used. And I'll come a little bit later to the terms used. Basically, I'm using everything. And that too is different from the sort of common practice where one does stemming and lemmatization and stuff of that sort in order to reduce the word set. But I'm more interested here in having a data-driven, bottom-up approach, and I want to convince you that it works very, very well in certain circumstances, particular circumstances, as all methods will work, and that there are many avenues of further exploitation, some of which we're pursuing ourselves. So just in a metric, this is the mathematical definition of a metric relating to 3 observation vectors or points in the space, which typically is higher dimensional than what we see here, the planar or 2-dimensional representation. It serves me well, though, just for the representation. And then compared to that triangular inequality, which we had a few minutes ago, here we've got an inequality, and this defines between any 3 points or observations or terms, whatever we are dealing with, the vectors we're dealing with, it defines the relationships between them, and this gives a tree distance. And this tree distance is well known. For instance, this is an ultrametric distance, the closest common ancestor in these terms. Just by way of, and I'm not going to go much into the mathematical underpinnings of correspondence analysis, suffice to say that it's an eigenvalue-eigenvector decomposition method, hence order p cubed in terms of the computational complexity, but you work on either the rows or the columns, so therefore in the cases that I will be showing you, scenes crossed by terms. The term set is often 1,000 or a couple of thousand. Therefore, one will work from the point of view of the eigenvalue eigendecomposition on the scene set, the set of scenes, which is usually a much smaller set of values. We can come back offline or otherwise to talk about computational issues later, but in many, many respects what I will be showing you are not quite real time, but not far off, so therefore quite practical from the point of view of processing data sets of appreciable sizes overall in terms of input matrix size, if one wishes to view it in matrix terms, and that is relatively practical. So in terms of one of the spaces we're dealing with, because we talk about in the correspondence context the dual spaces of rows and columns, the scenes crossed by the terms or the observations crossed by the attributes. And this must be a positive set of measures. So typically, frequency measures are what is at issue in a context like this. We have masses which are defined, which are weights, which are row totals or column totals. They're actually normalized by the sum total of the entire matrix. And then we have a chi-square distance, which is, if you like, a weighted enhanced version, so to speak, of the Euclidean distance. And if the weights are constant in terms of the marginals on rows or columns, then we will have this collapses, if you like, or becomes just the regular Euclidean distance. So it's a slightly different distance, which has certain interesting properties. There's a certain property called the property of distributional equivalence, which means that if we have 2 rows, for instance, in a data matrix, which is endowed with the chi-square distance, and if we just sum those 2 rows, because let's assume that they are counts to begin with, and we want a slightly more gross aggregation level and so on, that has no effect other than the immediate local effect on the analysis. And that's handy, because it gives a certain invariance, a sort of a scale invariance property to the types of representations which we can get by projecting into Euclidean space. So this is just by way, therefore, of a few words. This is the dual space, very, very similar, but just we're talking about rows versus columns in the data matrix. So that's the kind of, by way of background, and I'll just come in a moment to why ultrametrics are important, namely hierarchical distances. But here, anyway, is what I want just to look at. The web of relationships is very well captured by the mechanism of correspondence analysis, whereby each row vector is given by a particular weighted average of all of the column vectors, and reciprocally, vice versa. So that means, therefore, that you can, in a very particular sense, and this is manifested then subsequently in the projections that you have, the visualizations, you can say that an observation, let's say, is at the center of gravity in a very particular case, because we're talking about particular weights used here, center of gravity of all of the other observations in terms of its dependency on them. Similarly, we can say that an observation vector is at the center of gravity of the attributes which it is related to. And that is important then for interpretation point of view. And we'll see later that the scenes and the terms used, for instance, the observations and the attributes, are in the same representation. So in the case then of, I want to look at how we can pull in the evolution over time. And that I'm going to do just in a moment, because I'm going to essentially use the correspondence analysis and metric analysis framework for what can be called the geometry of information. And on the other hand, however, the topology of information, a tree structure, I'm going to use for not just the timeline, because I'm constraining the hierarchy to take account of the chronological sequence that we're dealing with, namely in the film script context, the sequence of scenes, and that I want to show captures anomaly and change. And here's the deal, really. Let's say that we've got a search problem and we're trying to search for information, and each of these points represents, in a high-dimensional context, the query term. And therefore, the red term here is the query one, and we want to find the closest matching element. So in this case here, we have a pretty clear situation where that is the closest that we want to deal with. Now, however, consider a situation where we have a query which is way off. And this, to my mind, represents, just adequately, schematically, an anomaly, something different from all the others. So we can ask, how do we measure, how do we really capture proximity in this context? Of course, we can use the traditional approach and basically look for the closest, but I would put it to you that closeness in this case is not particularly, necessarily anyway, not particularly useful. We're talking about a bunch of data down here, which is really all much the same distance from this other one. And to the approximation that we can say that we're dealing with, therefore, an isosceles triangle with approximately equally long sides, that is one of the fundamental properties of an ultrametric space. A space, in other words, endowed with a metric, which is a tree metric, a very particularly strong metric. And the only other possibility in terms of triangle configurations relative to the Euclidean context is that we can allow equilateral triangles also in this context. So that was just by way of some background on the mechanisms, the algorithms which are used and which will underpin this work. And I wrote a book published in 2005, and it deals with this, and therefore I feel that in many ways, what is being dealt with here is a tale of three metrics. It's converting between them. Now, so semantics, therefore, this is correspondence analysis allows all interrelationships to be handled in the same way that processing is carried out, taking data which initially is, let's say, frequency of occurrence information, and then endowing that to begin with a chi-squared metric, and then mapping that through eigenvalue, eigenvector decomposition into a Euclidean space, and taking that Euclidean data and endowing it with a tree structure, which furthermore is a chronological structure taking account of change over time. And that's that second one here. And anomaly and change constitutes a big issue in regard to what we're doing, as we will show later. For instance, in film script, it's a matter of finding the big changes in the narrative. Or we've been playing around with this somewhat more recently, blog trains or other types of literary works, for instance, looking for the internal structure, including in particular anomaly and change in that context. So I've described the mechanisms which we're using, and I want to just to basically position that, especially if you are reasonably knowledgeable about these techniques. I want just to put it in a general context. I also think it's important because the methods used obviously point to, what it can do overall in a data analysis framework, and that I'm going to move on to now. So this roughly is what I'm going to be dealing with over the next while. I'm going to just take the Casablanca movie, and it's always struck me as interesting that the script was only half completed when production began. So interesting enough in its own way, and this then is a collective work. At least I'll have some things to say, a little to say about the CSI popular television series a little bit later. But an interesting thing about those is that there too, these works of this sort, the production work, is extremely collective. That in turn is an added argument as to why one should be using techniques of the sort that I'll be surveying and presenting to you in this context. So the Casablanca script itself has 77 successive scenes, and as mentioned, I'm using a sort of data-driven bottom-up approach, and some restrictions are imposed without undue loss of generality. Like, for instance, punctuation is ignored here in this context, and also every uppercase letter is put to lowercase. Furthermore, numeric information. This could be an issue in other areas, a loss, let's say, but here I'm ignoring numeric information. And also words have to be more than 1 character in length. Fine. It's without undue loss of generality doing this, and the whole processing can adopt a different approach here, can take these into account were that necessary. And frequency of occurrence, occurrences of the words in the scenes, and the impulsive matrix crossing these things. And now, I mean, one of the aspects of our work, our joint work with Adam and myself, is that I feel that from the point of view of the digital of the humanities, of media arts in particular, where I really like this, because I can take the insights and the absolute deep knowledge that Adam has, but here even more specifically is something which played a major role in this, and it's this work by this author McKee. It's a substantial book, 400 or 500 pages, and it, to my mind, deals very nicely with how one can define features in something like a script related to Casablanca and the like. So basically taking the discursive discursive work in this work by McKee, I've translated those into algorithms, and even gone further and developed Monte Carlo testing so that one could say if particular features were particularly significant, even if one wished, statistically significant, by permutation testing relative to the given film script in the case that we have here. And what triggered that in my mind initially was for McKee to say that the composition of the movie Casablanca is virtually perfect. So I sort of, as a kind of a hard-nosed or whatever computer scientist, well, of that background, sort of said, well, yeah, well, how, like, and what can be done? So my mind immediately went towards thinking of possible features that one could actually use to do to validate that and to give meaning to it in an algorithmic sense. So I'm going to look therefore at just mainly at one particular climax scene. Apologies that there is something a little bit cut at the top of the slide, but it won't. This is a pivotal scene right bang in the middle of the Casablanca movie, and it's one which is described just in what you see here. Ilsa and Rick have a sort of attraction repulsion type of set of moves, and these are the moves are in sub-scenes, and the sub-scenes in this book by McKee that I mentioned just a moment ago, in that book, sub-scenes are referred to as beats. So therefore we have these 11 beats or sub-scenes, and just descriptively you see here the coming together and the going apart, so to speak, of these two characters in this scene. So taking the words alone in this scene. We have them represented here, and we have the 11 subscenes represented by the numeric values, labels here. And just so as not to clutter things, the words used, the terms used, are represented by the dots, 210, for this particular scene with its 11 subscenes. And therefore, one could, for instance, see what characterizes subscene 11 in terms of words which are close to it, and that can be very useful in certain circumstances. One can also look at, in the case of these two factors, these two principal components, if you wish, two underlying dimensions in the correspondence analysis output. One can look at why this is extreme relative to, let's say, subscene 1. But what is more interesting in regard to this scene, scene number 43, is to look at something, as I will show you now in a moment, related to the emotional content of the original film. And I felt it was really nice to be able to capture that in something as abstract in a certain sense in regard to what we see here. And what you have here with the red arrows is just the trajectory of some of the successive subscenes. So therefore, subscene 2, 3, 4. And here, 7, 8, 9, 10, 11. And therefore, it's just interesting to look at what those subscenes mean in terms of the original description or, of course, the original text of the film script. And what you have is that the movement from up the diagram, in other words, from the negative side to the positive side of the vertical axis is one of repulsion. Attraction is coming down this axis. So, and this over here is quite anomalous. And therefore, if we want to find something like this automatically, just come back to that maybe in a moment, but I'll just look at this, that in the chronological clustering, for those who know, this is using a complete link hierarchical clustering criterion, but which is constrained to take account of the given adjacencies, which are those given by the successive subscenes in the case of what we are looking at just now. But what we see here, oops, sorry, this is, oops, excuse me. We see here that in going from subscene 7, you see that in the hierarchy there is a big jump relative to where subscene 8 is pulled into the hierarchy, because this is a set of agglomerations whereby we start off with the set of subscenes in this context, and we have them in a high-dimensional space, or I think in this case it is the full dimensionality analysis. So that is not just the two-dimensional display that we that I showed you, and we have therefore this as it being nicely picked out in the hierarchical tree. And it's easy enough actually to develop a little further algorithm and say exactly where the big turning points are. And that's something I'll show you later with books and other things. And as said, we're playing around with that with blog posts and with comment trains and so on. So therefore, looking at the narrative and looking at the changes and the trajectory of the narrative and why one might want to do that is exemplified through the fact that it may well capture emotional or other substantive or maybe just equally useful as a term here as to what we're doing, semantic content of what we're dealing with.
Can you,
yes.
Can you substantiate your claim, if you go back to the map, so to speak, that this goes from attraction to repulsion by giving some examples of what words were actually prevalent in those areas?
Absolutely, absolutely. So now I won't be able to answer it right now because I will have to go back and look at it, but I'll tell you exactly what words would be relevant. I mean, the bunch of words which are, let's say, down here and so on the one hand, bunch of words up here. And there's just one other thing in correspondence analysis which actually is very helpful in practice, and that is that one can appreciate from a diagram like this the projections onto the axes, right? So, you know, a term like this is projected. Because this is Euclidean space, it's orthogonal in terms of the projection. But there are two other measures which come into correspondence analysis, the so-called contributions to the inertia expressed by this, either of these axes, which represent in successive order of importance the principal axes of inertia in the analysis. That's one thing, contributions. And the contributions are a bit like projections. They are measures, they are values for how important, you know, let's say a given term is for that particular axis or axis. And similarly, the correlation is the degree of, relative to the origin, it's the cosine of the angle of the point of the term with the axis. So therefore, looking at those three things, and in practice, I would typically look much more at contributions and correlations to explain the importance. But certainly, you can find the terms which are the most relevant in that way.
And if I can maybe just say something from the kind of screenwriting point of view, it may seem kind of ridiculous, but actually, that's what a screenwriter is trying to do. In any time that you're using a set of language to create a mood, and then for the reader who's reading it, and for many different purposes, because you want them to buy it, because actors are going to have to translate the emotions and read a combination of dialogue and text, they're going to need to feel the change of rhythm, the change of language used to mark those emotional changes. So it may seem, on the one level, unbelievable that all of this information can be detected, but actually all you're in fact doing when you write a screenplay is trying to make people feel in real time that the nature of the thing has changed. And so you will obviously use different kinds of language to show that there is a more extreme emotional thing that has happened. If I say, I love you, I love you, I love you, I hate you, that will, you know, and I will then start to say, you bastard, or whatever. I should be talking in this. So we will mark that.
Perhaps not with that.
Yeah, we will mark that moment of change. And the more different it is from what has previously occurred, the more we will, and the audience will feel that change in real time. So on the one hand, it seems extremely unlikely. You have to be remember that this is text that has been created to absolutely achieve that purpose. All we're saying is that actually one can start to detect that purpose when you compare, you know, the individuality of any scene against the totality of the language used.
Okay, and as thank you, Adam. And as also mentioned a few minutes ago, why is Casablanca perfect, right? Well, here were indications or guidelines, whatever, from the book by McKee, and this, for instance, he talked about the lengths of the beats subscenes getting shorter, leading up to a climax, which is a longer one, and precisely that can be found in those subscenes. So therefore, coming to a climactic end, you have the beats. Here I have the numbers of words in those successive subscenes. And therefore, exactly as McKee says, smaller, 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 and then bang, up again, climax. And then let me just see what else I want to mention here. And I don't think I will mention anything here, but just move on to, again, following up on this and how one can use that sort of approach, using, if you like, sort of meta features, or at least features which are defined based on the words used, right? But I just point out to you that it's very convenient in this work to have a Euclidean representation because it's so straightforward on the basis of a Euclidean embedding of the data to be able to then subsequently define features related to trajectory or orientation or things like that. If you do not have a Euclidean context, you've got immediately a headache with regard to how you normalize the data. And of course you can use inverse term weighting and various possibilities like that, but at least the Euclidean framework constitutes an excellent basis for that further, deeper exploration of the data. And that's what we see here, just summarized, just a little bit, in terms of what we're dealing with. I'll just have one other slide showing you this type of approach in a moment. This is the type of outcome that we get in terms of these features or meta features, if you wish, describing the Casablanca work. And why would one want randomizations of the subscenes? In other words, subscenes in an order which is different from the perfect work of art, which we're dealing with. And well, if one wished to consider that sort of benchmarking, if one takes 999 alternatives which are randomized, then you have a statistical hypothesis test at the point 0.1 level. So in other words, you can have a totally correct statistical test here if one wishes to do that, based on the permutation testing, permutation basis for what we're dealing with here. And therefore, just going on and looking at this for the this is the entire Casablanca movie, and various attributes of the sort that were looked at just a moment ago, namely tempo and rhythm and so on, given precise algorithmic definitions. Rhythm being, tempo being essentially a difference term from position at one point relative to the next. Variability comes into that. I mean, that's just variance or some such term. Standard deviation, it's all the same. Second order moment, in other words. And therefore, one can define a bunch of those. I'll give you a reference at the end as to where, there's a precise description of what was done there. And you can see, therefore, that then allows, on the basis of as many randomizations as you wish, because here I've just stopped at looking for just the number of cases where things are exceptional in their own way for this Casablanca movie. So that is my answer to why Casablanca is perfect, namely because on measures of this sort, it comes up trumps. It comes up as being very good, and therefore that's a way to instrumentalize or put into algorithmic terms the more artistic point of view and, of course, expert point of view of what McKee did in that context.
Can I ask you a question?
Yeah.
So just to clarify how this works, you sample the random permutations of these scenes. You create 999 samples.
For instance, yeah.
You have certain features like how much does this wiggle around from scene to scene in that order.
Yeah.
And that gives you a number, and then you look at what's in how many of those 999 cases is that greater or smaller than in the original.
Yeah.
And then the first finding, is that correct to interpret it as that there's a smoother trajectory in the original piece than in 38% of the randomized ones where it moves more erratically about this?
Yeah, it could be precisely of that nature. Yeah. Yeah. Because I'm not going to look right now at the actual example, but it's precisely that line of thinking. Furthermore, the wiggles, that is something where expert judgment is needed as to what constitutes an interesting type of wiggle, trajectory and so on. That's where I would absolutely rely on the deep knowledge that Adam has, for instance, of that. And the McKee book, I am saying too, was just great in terms of discursive, qualitative views on this, but which could be captured in algorithmic terms, and that's what was done here.
Just to say that I think one of the interesting things about the screenplay is that there have been heuristics developed to make things that work pretty well. Do you know what I mean? Which work pretty well in real time, tested developed, as I was saying to someone at lunch, in Hollywood, which had to make films addressing millions of people who might be kind of in New Orleans or New York or Idaho. They might have no common mythical reference points or whatever, and actually people had to make and became expert at making narratives that could be watched in real time and understood in real time. And one of the really interesting things about the screenplay, and I've written a chapter in a book about it, where a screenplay is a brilliant self-teaching system. Every film that you watch teaches you how to watch it in real time. That's to say, you may know the context in which the film is set, but you may not, but if not, the film will make sure that you have all the information in order to appreciate what is at stake for the characters in, not just in their own world, what happens between this group and that group in Microsoft. At some point, I will need to understand that if you set a romantic comedy in this context, or you set a revenge murder or whatever, you will need to understand all of the metadata in a script. And screenplays are actually incredibly good at doing that. And McKee and others have kind of outlined, mostly for people who would like to write movies. McKee appears in the film adaptation, played as a character, but pretty well. Not 100% of the time, all of the time, but pretty well that most successful films have most of these properties. So it's a kind of description of, those heuristical rules.
So as basically a newbie and as a person who just watches movies, right? Sometimes you take, sometimes I take these things for granted, right? And you are absolutely right that the movie has to basically explain it to the audience how it should be watched. So can you give me an example of a screenplay which actually does not have that?
Well, a film which you didn't like, or you walked out of, or you couldn't understand, or you couldn't be bothered with. I can give you, but an example of a really brilliant film, let's say, is Groundhog Day. You've all watched Groundhog Day, presumably. Now, this concept didn't exist. In fact, people now say it was like Groundhog Day. Now, there's never, you don't get a handout or a PowerPoint presentation about what Groundhog Day is. But what happens is that you empirically observe what the Bill Murray character undergoes, and you work out what those rules are from the evidence that you're given, which is originally, of course, presented in the text, because the text is the kind of prototype of the movie. So what we're, in looking at the text, you're kind of seeing how those rules have been work, and actually we kind of logically deduce, it's a bit like that game in Euclid that Martin Gardner talks about. You have to work out what are the properties that make a character behave in a certain way, and therefore what will make them change, right? And there are many kind of things about thinking about the mathematical properties of characters, or the ways in which a screenplay is, of course, a visualization or a pleasant oversimplification or theorization by putting things in a narrative at all, says that things, so we can better see the patterns either in our own behavior or other people's behavior or whatever. So the text is written in order to make certain things more apparent. And what kind of the work is doing is, yes, it seems that one can find the ways in which the text has been distorted to make things more apparent. Then, of course, actually, those traces will remain in that text because they were deliberately put there. And we will, we will also kind of feel that as we read it, and we will learn it as we read it. And there are lots of techniques used from rhythm, from language, to make us from kind of exploration or names and the characters to whom the story happened, so that we will kind of understand those properties without realizing it. And also, the great film is you really don't realize that you've learned this kind of stuff because you're paying so much attention to the narrative that the other feels incidental.
In fact, with Groundhog Day, you would imagine that those scenes that always start the same with the alarm clock ringing, that because they deviate from
if you think about the mathematics that people do about catching a ball, you know, and actually in order to catch a ball, a baseball or a cricket ball, you have to go through incredibly complicated mathematical trajectories, but in fact, you just go like that, you know? And I think it's similar that actually our understanding of story and story timing and rhythm is something that we've been paying attention to since the age of 2 or 3, maybe, you know, so we have a really deep sensitivity to those kind of patterns. You know in a movie when a pause lasts too long, it's quiet, too quiet. Do you know what I mean? And actually, again, the text is designed to make us feel that. You know? Therefore, it should be possible to find out those ways in which it differs from randomized things, because it's meant to. It's meant to kind of make us be aware of certain things.
I think it was very interesting to actually look at the recordings of lectures at MIT or Harvard and Stanford, and then there are certain sort of professors who would come in and then basically tell you, here is the theorem and here's the proof of the theorem, and the students are like, okay, that's basically the end result, and nobody's excited. And then there are certain professors who actually just build this thing up, right? And then they suddenly say, here is the answer, and then students get it. Students actually
and there's, I mean, there's, you know, if we start thinking about narrative experience, I mean, so, you know, there's a lot more to talk about. But just one thing I would just very briefly say is actually, of course, there is the creation of an illusion. I remember seeing the Chinese state circus, and at the end of the culmination, the guy, you know, walks on the tightrope, and at the final end, he, you know, has to cycle up the tightrope at the top of the, you know, and he fails twice. And then he does it, and of course you think, actually, you're so used to the fact that he can climb the tightrope, you've forgotten it's dangerous. So it's necessary for him to fail, so that there is something at stake when he succeeds. Because, and in fact, the thing is, what's important always is rate of change. Do you know what I mean? Because we very quickly adapt to, it's the law of the inverse ninja law, which I learned over lunch, you know? In order for something to feel threatening, we have to feel that something is at stake. If we get used to the fact that the guy can kill 100 ninjas, he's not in danger anymore. So if we get used to the fact that the guy can walk the tightrope, there's nothing pretty interesting about a guy who can walk a tightrope, because, you know, I can't, but you can. So we have to feel that it's dangerous, and somehow we're finding these engineered patterns and able to find them textually.
Let me move on, okay? Is that okay? Right. But our work there actually, as just described a short time ago, captured quite a bit of interest, and the journal Nature, for instance, did a discussion on it. Not with our involvement, they just went and found our work and described it, and we were quite happy about that. But here's another area. We have no connections at the moment, anyway, with these people, but this also captured quite a bit of interest, and it was using a very similar approach. Now, relative to what we're doing, our features, the sort of meta features that I looked at, are algorithmically well defined, right? Very implementable. Whereas here it's more a matter of judgment and filling in a form or something of that sort. So it's another approach, and it works well, and that's an article which describes that particular work. So in other words, we're looking at story semantics, we're looking at narrative, we're looking at how narrative changes. It's based on the web of interrelationships, instrumentalized or made operational by the correspondence analysis embedding. And then we're looking at caesuras or breakpoints, etc., changes in the narrative, and that is especially aided by the hierarchical structure and the chronological hierarchical structure. This has been done on CSI. This is a bit of video which is not playing here. It doesn't matter though, and you know CSI anyway. And I'll just say a few words, very, very basically, about our work here, because there are some published references, at least one anyway, which I can point you towards. And here, for instance, again, I would stress very much a team effort where a certain type of style has got to be preserved, therefore that to begin with. Secondly, the problem-solving aspects of CSI makes it an ideal model in many ways. And the scripts of CSI have been, I stress have been, all available on the web. which is ideal, but from a third-party site. So in joint work, which we were trying to, we are really pursuing with, in San Diego, the UC San Diego Center for Research in Entertainment and Learning, and we got a legal judgment on whether we could use such scripts in the context of a UK-US project. The US side said yes, no problem. The UK side almost certainly not, because notwithstanding the fact that they were in the public domain on the web, this relates after all to, you know, a major commercial enterprise doing the CSI programs and all the rest, and therefore whatever about the availability of the data does not necessarily mean that you can use it. And even for research purposes, you have to be a little bit careful. So just flag that as an interesting aspect, where I see certainly an aspect of our work ultimately in terms of you know, monitoring aspects of rights which are associated with texts, and then looking for the context in which those multimedia objects above and beyond texts maybe are to be found in practice. It's an idea but I'll just leave it at that. Here is therefore one of the CSI episodes, CSI Las Vegas. I think it was a very initial one, a pilot one. And therefore, just to point out to you again, the type of thing that we do. I mean, this is, you know, in the nature of any visualization, it's heuristic. Up to a point, it's heuristic and exploratory, you know. I mean, obviously, we can test it statistically. Using some model of the sort, you know, a stochastic model, a Monte Carlo approach, for instance, that's straightforward. But I just stress that, fine, it is heuristic, it is exploratory, it is based on, partially anyway, on visualization. But nonetheless, it can be downright useful in practice, and therefore the practical aspect is to associate what findings one has with the reality of a work environment, the reality of a collaborative context, etc., etc. And here, for instance, we have, you know, big changes at number 5 here. This is the scene in this CSI script, and this one comes in quite late in the day relative to the set of agglomerations. Here too, 15 is quite exceptional, and so on. And it's that sort of thing which we want to look at in order to say, where are the biggest changes taking place relative to sort of segments which are pretty homogeneous, or homogeneous to some extent, right? And don't forget that in talking about homogeneity or change, etc., we're using the data. It's data-driven, and it's actually word and word relationship-based.
Yeah, just one question about that. When you take the script, I assume it basically says character name, colon, and then what they're saying, right? Do you keep the character name?
Generally,
because
yes.
that would then give a lot of weight to which characters were actually active in the scene.
Yes.
If two people have a dialogue, then their names would be repeated all over the place, not only in that section, but also when they address each other by name.
Yes.
So that's being used.
And it's very important in practice to get the interplay of the male protagonist and the female protagonist, maybe in CSI or something, and to have balance, etc. There are aspects of the ambient context which also give balance, or break from the balance, you know, as the case may be. But dead right, that is important. And again, I think that a kind of an interest really, like on my side, has been to take the data in as raw a state as possible in order to have an approach which will work well in practice, but to validate it though. Validate it absolutely and totally on test cases, especially with regard to expert judgment, in some cases with regard to statistical approaches. Right, so I just mentioned those as how we have to, as one has to have the performance evaluation, that sort of evaluation and validation. So now, having looked, I mean, in many ways, this has been sort of the analysis in the sense of breakdown of the constituent parts of text and all the rest. And I'm going to just have a look at our work on text synthesis. How can we use this approach to actually put together larger bodies of text? Right, and I kind of like to quote, you know, these days of citation practices and so on. Here's my citation from 350 BC, you know, and Aristotle on agent computing and so on. So it's good, like, and this here is relevant just in terms of the approach that we're using. So it just suits us well. And here I'll just outline and then just give a few summary points from what is done here. Basically, a recent PhD in Royal Holloway, Joe Reddington, worked on this. And it was kind of really interesting work. He worked twice in succession with an English language class in getting them to do creative writing and to put together a novel in the space of about a week in both cases. And he got the class to have certain characters, but also to assemble different parts of the text, and then applied the methodology which I've been describing in order to see what the overall structure was like, represented, for instance, in particular by the hierarchical structure of what it's doing, and to critique it on the basis of that. So here you have some images of his class, and here is what was at issue in that work, namely pinpointing anomalous sections. Maybe not. Maybe that's precisely what you want, but not necessarily. You may want to at least discuss it and critique it. Assessing homogeneity of style over, for instance, the successive iterations as the work was being progressed and eventually, presumably, converging on a full piece of work at the end. And then scenario experimentation and planning by having particular ideas being put into practice, look at the structure of what that gives overall, and then knock it out of consideration if one wishes or otherwise, or expand and so on. So condensing similarity in structure relative to the best practice in the genre. And after all, films, books, etc., all have their aspects of genre and that type of thing. So this was really kind of cool enough, and we got a teaching prize just over 1 year ago in Royal Holloway for that work. So it was kind of nice. And Joe Reddington is continuing that with in a kind of social, certain types of teaching of kids, and also with aiming at social inclusion type of things, because there's a lot of kind of good therapy kind of involved when you get down and collectively try to put together a collective piece of work. The novels that were written, two of them were locally produced in book form. So neither Joe Reddington nor ourselves claim that this is world literature, but it does its job in a particular context. Just some further examples of bottom-up integrative creation of multimedia objects. I just mentioned these as examples of where this really is very, very important, even outside of a teaching context. I really like this book, William Gibson anyway, but that's basically stitching together bits of video and so on into something much bigger. Now, in the case of some of the other areas here, we have a situation where there was mutation from one medium, or changeover from one medium to another. And here there is collective work, crowdsourcing type of work. So in other words, for this type of purpose, I think that it is no harm to say that there's interactivity here between the creators of the work, or the users, as the case may be, and what is happening. But I think it's valuable not to have, or not to even aspire to necessarily having a completely automated production line or pipeline, but instead to have an interactive context framework within which one can support the interaction and the focusing in on, or the ultimate targeting of the finalized work. Here then is just something else in regard to some of this, and I'll just show one slide on this, where we have the structure created and then access to the different chapters in a book. And this is done on a clickable, and the text comes up in the other part of the display. And that's something which we're pursuing at the moment. So
I think, are you going to wrap up soon?
Yes, I will. Could I have 5 minutes max? 4 minutes, okay.
Yeah.
Right, 3 minutes. Okay, yeah. I'm going to quite quickly. Just this is more general comments. We've seen books, at least the structure and the ability, therefore, to read the book from looking at bits and pieces of its structure here, there, and everywhere. If one wishes, though, do it in sequence as one would typically do. Not necessarily, though, because this will at least allow you to find where the big change points are. Blog trains and comments on articles and postings on news media sites. That's something which we're looking into at the moment, just in terms of this and getting a little demonstrator going and the like. And blog role analysis, why do we want to do that? Well, turning points in the blog chain. We want to see what postings semantically span the whole thing. What are representative or non-representative? Who's trying to put in something of an advertising nature? Maybe you want to do that. Maybe that's your job, to put in something of an advertising nature. But the fact is that, you know, this allows you to at least get a handle on what is going on and to see in a particular way how this comes together. Here's what we want to do just in terms too of going beyond traditional hub authorities and instead to take into account the semantic content of what is being dealt with. The quotations here generally are from this own technical report, which so therefore it's our own quotations, quoting ourselves. But just to summarise some of the issues which arise, that even short, snappy blog postings, which may be useless in other contexts, nonetheless can be useful in other ones. And the particular analysis carried out here was one relating to the Irish economic situation just at one of the times when political decisions were being made to pump enormous amounts of money into the banks. And therefore it was a discussion by economists about the rights and wrongs of doing that. Just some background information on correspondence analysis, because I think I will almost just be finishing off now in one moment. And maybe I will just leave this for what you see here and not say anything further about it. There's been a bunch of publications arising out of this. Again, this is something which, by all means, if there's some particular aspect of what you've seen and are interested in, let us know, and we'll see if we can directly point you to this work. And if I could have 30 seconds then just to say what I'm not going to deal with here, because I was going to look at quite a different context of change over time. And this is related to a very major database related to the horrible things which have happened in Colombia in the past in terms of the drug barons and the wars, and especially the deaths and injuries of civilians being especially affected. And this data was related to the narcotics industry sector, if you wish, in Colombia, and looking for change. So I'll just, therefore, we looked at the correspondence analysis, the polarities, the major aspects explaining the data, and you see civilians versus guerrillas, and anti-government guerrillas versus government forces, and looking for change over time. And then that was related back to the major changes between certain years, this gap, for instance, in this figure, and this gap in this figure, and what that was explained by in terms of political change at the top in Colombia, and also certain types of activity. There was some very major attack launched on guerrilla sites at some stage, which is in association with one of those big changes, and it meant a big retreat in a sense for the guerrilla forces at that time. So just therefore to leave you with this as a very different type of analysis based in this case on numerical data. I must say though that the numerical data here came from news media and the like, and other forms of statistics. It was all gathered from news media to begin with, converted into numeric frequency of occurrence type data, time, place, atrocity, what happened, etc. And then it was that data which has been analysed here. And that work too has been published in that article. So that's the end. Thank you.